Hi, welcome to online tutorial series on Arduino and IoT. In this lesson, we will learn how to generate analog voltage, or we can say the variable analog voltage from Arduino UNO pins. Okay, so we also provide online training and online tutorial classes, and we also do help in technical assignments, and we also make freelance based project based on embedded system, LabVIEW, MATLAB, data science, machine learning, etc. So if you have any such requirement, then you can let us know by contacting us at www.jcbrolabs.org, or you can mail us at jcbrolabs@gmail.com. So let's start. When we talk about generating analog voltage, that means in our last video we talked about how to convert the analog voltage, let's say 0.5 volt, into a digital one or inside the microcontroller. Today we are going to talk about how to generate let's say 0.5 volt or 1.5 volt at any pin of the microcontroller. So first we'll go through the concept of it. So generating analog voltage, there are two concepts. Either we have DAC, which converts digital to analog, but microcontroller or this Arduino Uno don't have any DAC. So there is another method which is known as the PWM, which is generally used to generate this analog voltage. It is known as the pulse width modulation. So this is a technique through which we can generate any specific analog voltage at any pin just by generating a pulse width modulating wave. So what is pulse width modulation? As its name suggests, it is simple a pulse whose width is being changing with respect to time. So if we talk about our digital pulse, so our digital pulse looks like something this. So we are taking an example digital pulse. Okay. So this is a simple digital pulse. Now there are two things in digital pulse. This is the complete time period, or this T, right, which is equals to 1 divided by the frequency of the pulse. And now there are two time periods. This is the T on, for the duration for which this pulse is on, and this time period is the T off. So this capital T is equals to T on plus T off. So what will happen? Now there is another term which is defined as the duty cycle. So duty cycle is equals to T on divided by T. Okay. Now if we are representing this high as plus 5 volt and this low as 0 volt, so the V average voltage value which we will be getting here, that will be simply duty cycle into 5. Okay, so that is the maximum value. So let's say, or in generalized we can say, if it is VCC, so average value will be simply duty cycle into VCC. So if we talk about a 50% duty cycle, let's say duty cycle is 50%, that means 0.5. Here we are not multiplying it by 100, generally it is multiplied by 100. Let's say duty cycle is 0.5, that means T on is equals to T off. So in this case the average value which will be getting from this waveform, that will be 0.5 into VCC 5 volt, 5, that means 2.5 volt. Now let's say if we change the duty cycle to 10%, that means 0.1. So the V average value will be simply 0.5 into 5, that means 0.5 volt. Okay, so this is how we can change, just by changing this duty cycle we are changing the average value which is available at a particular pin. Right, now there are certain things which needs to be taken care of. This F or the time period, this F should be high. High means near about, let's say, greater than 500 hertz to in the range of 1 kilohertz. Because if this frequency is not high, you will be getting suppose if you are connecting a LED to it, so you will be visualizing the LED as on and off. So it should be high so that the latency is high, right? And this F needs to be constant while changing this T on and T off. Okay, so this T remain constant, this complete T, we only change this T on and this T off in order to generate this PWM. So this is the basic concept of PWM, and very simple one. So it is just by generating this kind of pulse wave at any pin, we can change the corresponding voltage available at that. So we will visualize it in Arduino UNO. So if we talk about Arduino UNO, in UNO there are 6 pins which are used to generate. Pin number 3, 5, 6, 5, 6 and 9, 10, 11. 9, 10 and 11. These are the PWM pins at which PWM is generated, and on all these we can generate a variable voltage just by doing a small programming. Now there is a command in Arduino which is used to generate this pin, that is analog write. So it is the pin number and the value. Okay, so what it does, this simply generate a PWM signal, PWM or a PWM signal out of any specific value, right? So this value can go between, it takes only integer values, it goes between 0 to 255. So for 0 means T on is 0, 255 T on is equals to capital T. Okay, and it take the integer values, and this is the pin numbers. It could be 3, 5, 6, 9, 10 and 11, any pin which is supported by this Arduino UNO for PWM generation. Okay, so these two things needs to be remembered. Now one thing you should be thinking, let's say for example if we want to generate a 1.25 volt at pin number 9, then what should be the value we should be passing into it, right? So there is a mapping of it. So let's generate a mapping formula. Mapping means we have this input voltage 1.25 and we want to find the corresponding value, right? So here we have 0, this is 5, and we want to generate the corresponding value, that is 255. So again it is a simple linear relationship. Okay, so we want to know the equation of this line. So the coordinate of this point are 5, 255, and the coordinate of this was 0, 0. So let's say it is value which we, so if we, here it is, let's say y, here it is x, and then this y is equals to value. So if we try to write it, so y minus 0 equals to 255 minus 0 divided by 5 minus 0 into x minus 0, right? So this will be y equals to 51 into x. So this x is the required voltage which we want to generate, and this is the value which we have to pass into analog write function. So as we talked about, like we want to generate this 1.25 volt, so this y should be equals to 51 into 1.25. so y should be Windows plus R. Let's do some calculation. 5 into 1.25, 51 into 1.25. So it is 63.75. But as I said, we can only send the integer value, so it will be approximated by 63 only. Now we can also find like what is the resolution of it, or at what step we can generate this value, right? Because this 0 to 5, there are 255 steps are there, right? So our step size is simply 5 divided by 255. So that means 5 divided by 255, that is 0.019 volt. So at this difference, this value will be generated. So now if we are getting a 63 as y, so corresponding to 63 we can find out what will be the value. So total 63 steps are there, so we can write it like 63 multiply with 0.019. so it will be, the voltage will be generated, that will be 1.2 volt. Okay. So approximately 1.2 volt will be generated at the output pin. Okay, so these are the theoretical values. Now we will check on the Arduino whether we are getting exactly the same value or not. And now I hope you are familiar with the concept, like how to generate values and what is the resolution size, because we can have only 255 numbers for a range of 0 to 5 and so. Okay, so now let's write a small program and then we'll check how much value is generated. Okay, so let's open and let's create a new file, and first thing we will do is to save it. So we have saved it as L10. Now we will define a pin mode. The pin mode should be output. So we are using pin number 9. So 9 comma output, and we'll be generating the value, or we will sending the value on serial port as well. Okay, so now let's generate a value, because we will define here, and let's say well equals to 0. Okay, we want to generate a value of 1.25, which we calculated, this one. Yes. So L equals to 1.25, and then analog write pin number 9 comma value, and that has to be integer type only, right? So we will typecast this, because this is a float. Okay, sorry, we have to make it float, and this is a float. Now we have to typecast into integer, and then so this is the formula which we have written here, value into 51, and because we need an integer type, so we have typecasted into this float value into integer value. Okay, so now let's see, let's upload it. Okay. Now let's have a look on the hardware. Okay, so this is our hardware. So this multimeter, and this is to pin number 9, and now we are connecting this pin number 9 to the multimeter pin so that we can check the value. Okay, because we want to generate it 1.25 volt, generating nearly 1.23 volt. Okay, let's change it. Let's change it to 2.25 and let's see whether it is able to generate the value of 2.25 or not. Yeah, so we want to generate the value of 2.25 and it is generating 2.23. That's cool. That is very near to it. Let's say generate 3.5 volt. So at this pin, yeah, we are getting exactly 3.50. So this is how we can generate any specific value just by changing the PWM frequency from it. Okay, so here we will write a small program in which we will be changing the intensity of the LED once it starts from 0 and it slowly keeps building up and then it slowly keeps building down. Okay, so that it gives you a flavor how to use this PWM wave or for a LED intensity variation. So this particular concept can also be used if you want to change the speed of the DC motor. Okay, and then we'll do it in the next video. So now let's write a program to change the intensity of LED up and down. Okay, so in order to put the direction, we will define a direction value, so whether it is going up or down. So let's say direction 1, so 1 defines it is increasing intensity and 0 indicates intensity is decreasing. Okay, so we'll write first for increasing intensity. Let's say if dir equals to 1, we will increase the intensity in a step of 0.1. Okay, so let's increase the value. So well equals to well plus 0.1. Okay, so on each step value will be incremented by 0.1. Now we'll write this value. So analog write of 9 comma, again it has to be integer type, val into 51, and then we will send the same to the serial monitor, serial.println val, where we will be able to see what is the value. And then now if this, because once it reaches to 5, right, we have to change the direction. After 5 it should be decreasing. Okay, so we can do that by because we don't want it to go to 5.1, otherwise we'll get a kind of jerk on the signal. So you can try it. So we'll do val plus 0.5 is greater than 5, so we are checking for the one step ahead. Then we will change the direction equals to 0, right, and then we'll provide a delay of, let's say, 250 millisecond, so that it should like it is increasing smoothly. Now another one else, if direction is 0, we'll do the same thing because value has been become 5, so we'll keep on decreasing the value and then we will check for the value whether it is less than 0 or not, and minus. Okay, so that's okay. So I hope it is very understandable. First direction is 1, intensity of LED will be keep on increasing, and when direction has been reversed, the intensity will be keep on decreasing up to 0. Okay, so let's upload it and let's check, connect to the LED. Okay, this is a LED. So this is blue LED we are connecting it to blue LED. Now let's see the serial monitor. Yes, it is increasing. Right, and if we connect the multimeter to it as well, we can check it on multimeter. Your multimeter is not giving the right value. Okay, now let's check, see with the red LED. Okay, there is certain error because it is going to -1, so it is not changing the direction. So when well minus 0.1 is less than 0, we should be changing the direction equals to, okay, direction should be 1 in that case. Okay, so let's compile it again. Now let's see. Yes, it is increasing. And now the value, the intensity will be decreasing. Yes, it is decreasing. So this is how you can vary the intensity of LED. Or similarly, if you connect any DC motors to the driver, you can vary the speed of that particular DC motor, increasing, slowly increasing, and the slowly decreasing. Okay, so this is how we can use this PWM method to generate a variable analog voltage at the specific pins of this Arduino UNO, and the same can be used for speed control of DC motor as well. So that's it for this video. In our next video we'll be talking about how to control this LED's intensity and the speed of the DC motor with a potentiometer. Okay, so we will combine whatever we have discussed in last two classes, that means an ADC conversion and generating analog voltage into one program, and then we will move forward. Okay, so I hope you really enjoyed this video. So if you have any doubt or any suggestion, you can let us know by commenting below this video. Okay, and once again, we also provide online training and tuition in technical subjects. We also help in technical assignments. We also do freelance based project based on MATLAB, embedded system, Raspberry Pi, or Python, data science, machine learning, etc. So if you have any such requirement, then you can let us know by contacting us at our website, through our website, which is www.jcbrolabs.org, or you can also mail us at jcbrolabs@gmail.com. So that's it for this video. Thank you.